Alright, in this tutorial we're going to talk about painting on an image instead of directly on the panel. And we're going to do this for a couple of different reasons. It's more efficient, and it's also going to allow us to do things with a scale to make this program into a pixel paint program. So we're going to be editing the paint panel class, and in this time we're going to add a couple different things. First of all, we're going to add our own graphics 2D tool, private graphics 2D, and we'll just call this G. And so this is going to be the main graphics artist for our entire program. We're going to pass it around to the different objects and ask it to draw those objects. We're also going to need a buffered image, private buffered image. So we're adding these as fields in our paint panel class. This is going to be the image onto which we draw all of our stuff, and then we're going to display this image on the screen. And one final thing that we want is we're going to have a public static final int called scale, and we're going to say this scale equals 8. Now this is just a value that I came up with that makes it look the way I would like it to look. It also, because we're going to add a recursive method later on, helps prevent what we call Stack Overflow issues. So in part we're doing the scale in this pixel program to just make it make the algorithm that we're going to write later on, the recursive algorithm, not crash our program. Okay, so we have these new objects. We need to initialize them in our constructor method. So here we go, and we can delete this repaint thing because we don't need it to repaint at this point. So buffered image is going to equal new buffered image, and this time we want it to be scaled up. So it's actually going to be paint window. We're going to use the width of the paint window dot width divided by scale. This is going to be the size of our image, and then we're going to say paint window dot height also divided by scale. And then the final parameter that buffered images take is going to be a constant, and I'm just going to hit return so that you can see it. Buffered image, and this is the default or the base type that most often is used. Buffered image dot type RGB, type int RGB. That means that the data inside this image is stored in the format red, green, blue RGB, which is familiar to us. So now we have an image that we can draw on. But we need to, this is going to feel a little weird, and I'll explain what's going on here. So we're going to say G, our graphics robot, that is our brilliant little graphics guy who knows how to do everything with graphics in Java, but has very little common sense. We're going to tell that graphical artist where we would like that graphic artist to draw. And so we have to do this, just type it down for right now and then pause it and get used to what's going on. And then we say image.getGraphics. Okay, so this line of code, and I want to be very clear about what this is doing. It associates the graphic artist G with this image. This is the only location where this graphics artist knows how to draw. This robot that is our graphics artist, we're telling him, okay, this is the canvas on which you draw all your stuff. Anytime I tell you to draw something, this is where I want you to draw it. The reason we cast it to a graphics 2D image is based on how Java was developed. So this initially, image.getGraphics, was set up when the main graphics library was not graphics 2D, which is an updated library. It was set up when it was just graphics. So what this does is it says, okay, buffered image, tell me about yourself. Tell me where you are in memory so that the artist can draw on you. But it returns that data in an older format. So we need to say, okay, take this data and structure the data in an updated format, and then tell G about it. That's what this says. So now, instead of in our paint component method, we're not going to do any of this stuff. We're going to delete everything in paint component, and all we're going to say is G dot You know what, this is going to be confusing because G down here is also called G. So we are going to change this, the name of this graphics artist, to G2. So refactor, right click on it, refactor, and rename it, and we're going to name it G2 so that it makes sense what's going on. Alright, G2 is going to be the one that draws on the image, and then this graphic artist, its whole job is going to be to hang that image on our panel because it knows how to do that very well. So in this case, we're going to say image, g.drawImage, start at the upper left hand corner at 0, 0. We want it also to draw to the width of our window, paint window dot width, and paint window dot height. And then you have to say null, which I don't frankly understand at this point. That's something that we're not using, so we just say null, that last parameter in the method. So all this method does is it says, okay, panel G, the panel, the Java swing knows how to send over to us and then knows how to paint. This graphics artist just knows how to paint on the panel. So we say, that graphics artist, we just want you to hang the image starting at 0, 0, the upper left hand corner of our panel. We want you to draw it to the entire width of our panel and the entire height of our panel anytime we ask you to repaint yourself. That's all you do. So what we've done in this tutorial, and this is going to be all we do in this tutorial, is we've set up a new buffered image and graphics artist for our drawing. We've created the scale so that our drawing looks pixelated, so that it's blown up, and so that we draw on a smaller whatever, so it looks pixelated. We initialize the buffered image to the standard image format used in many programs in Java, and we have told our G2 graphics artist, anytime we ask you to draw anything, please draw it on the image. And that's all we're going to do in this tutorial, and we're going to use this image in the next tutorial to actually begin drawing circular tools, the circle tool. Anyway, so that's it for this tutorial. All right.